All right. Okay, let's talk about composite figures and shaded regions and all that nice stuff. Okay, composite figures would be shapes that can be broken up into 3 or 4 parts, and then you can find the area of each little part, right? Like half a circle, a square, and a triangle, and then add them all together. Sometimes you can subtract away a part. You know, like say down here, you could do the area of the square and then subtract away the area of the circle, and you'll get the area of the shaded region. Okay, so composite figures. Here we go. On this one, we need to break it up into parts. If you tried to break it up this way, it wouldn't work because you don't know what this one is, right? So probably best to come down this way. So we'll have a 1x9 rectangle. Then we got this one here. So rectangles are just length times width, right? So 12 times 7 is 84. We'll say inches squared. And then this one right here is 9 inches squared. And what's this middle one? We know it's 3 this way, but what is it this way? Well, this whole thing's 12. Subtract the 5, and this is 7. So 7 times 3 is 21. Okay, so we take 84, 21, and 9, add them all together. Oh, hang on a second here. 14, 114. Okay, inches squared. Okay, this is quite often it's a good idea to make a little plan. Like this is like half a circle, and then plus I don't know, a triangle, area of a triangle. And this is an equilateral triangle, right? Okay, so this is pi r squared for the circle formula, but we need half of it, so I'm going to put a divide by 2 underneath it. And then for a triangle, we're going to have a base times height divided by 2 formula, right? 1/2 base times height. And we need a height, don't we? Okay. And if it's an equilateral triangle, you know you break this up into 30, 60, 90, right? So this one's 60 and this one's 30 up here. So working on, let's do the half a circle first, okay? So we need a radius, okay? One side is 6. That side is 6 as well, so half a side, a radius, would be 3. So 3 squared pi over 2. So that's 9 over 2 pi. 9 over 2 pi. Okay, and I'll work that out in a second. And then base times height. Okay, the base is 6, right? And then the height, we go divide by 2, right? This is the hypotenuse side of the 30, 60, 90, right? So you divide by 2 to get 3, and then multiply by radical 3. So this is 3 radical 3. So this would be 3 radical 3 here, and you have to divide it by 2. Okay, the outside numbers are 18. 6 times 3 is 18, and then divide by the outside number on bottom, which is 9. So this is plus 9 radical 3. So now you just got to get a calculator if you want something more specific. Okay, so 9 pi. Okay, I'm going to hit enter, and then I'm going to divide by 2, and that's that. So I'm just going to go ahead and put 14.1 right here. Okay, and then 9 second radical 3, hit enter, and I get 15.6. So 15.6, that would be 29.7. Yay, okay, and that's inches squared. All right, shaded region. Ooh, 3 shaded regions. Okay, plan. Okay, area of a triangle plus area of a square plus area of 1/2 of a circle. Okay, so the triangle is base times height divided by 2. Square is just base times height, and then area of a circle will be pi r squared divided by 2, right? So base, the base is 12, okay? And then, can y'all see? Yeah, you can. Okay, so 12, and then the height, okay, you divide by 2 to get 6 here, and then this is 6 radical 3 for the height. So 6 radical 3, and it's not hard, just computational, lots of computation. And then base times height for this one, 12 times 12. Can I just, you know, this is 12 times 12. Can I just write 144? Okay, good, thank you. All right, so this is half a circle. the radius is 6, right? Because all these lines say that every one of those lines is 6. I mean, or 12, like this. So we put in a 6 here. So 6 squared pi, and then divided by 2. So that's 36 divided by 2 is 18 pi. Okay, so I've got the 144, and then I got to do some, that's 72 divided by 2 is 36. So 36 radical 3. So I got to add all those up. Okay, so 36, whoops, clear. Okay, 36 radical 3, whoops, back up, clear. Go on the outside. I'm going to 3, and then go on the outside. Now I'm going to put a plus sign. I'm just going to do it this way. Plus 144 plus 18 pi, and I get 262.9. Yay! And that's inches squared. Okay. Now, this would be area of a square minus the area of a circle, right? So square is base times height, or length times width, and this is pi r squared, right? Okay. The r is going to be 10, right? Half a circle. That's the diameter, really. So 10 squared pi, so that's 100 pi, right? And then base times height, so that's 20 times 20, right? Which is 400. This would be a beautiful answer. It's a perfect answer, okay? You might see it that way sometimes. Or you can get the approximation by saying 400 minus 100 pi, which would be 85.8. That's the approximation, okay? Either one's good. All right, so this one right here, area of a rectangle minus the area of 2 circles, okay? So the rectangle, 10, what would this side be? Well, diameter, 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 so 10 and 10, so that's 20, right? Okay, so that's 10 times 20 for base times height, right? And then the area of 2 circles minus the area of 2 circles, so 2 times pi r squared, right? Okay, r is going to be 5, which is half a side, right? So we plug that in here, so 5 squared pi, 2 on the outside here still, that's 25, 50 pi. Okay, 50 pi, and then 10 times 20 is 200, okay? And then you're going to subtract that. That's a perfect answer. It could be the answer right there. Let me see, 200 minus 50 second pi is 42.9. Okay, let's go to the back. Okay, here's the tricky problems, because we have to use regular polygons, right? But it's not hard. We learned regular polygons last time, right? Okay, so we're finding the shaded region. Like over here, we're finding, you know, all this shaded part, and then down here, we're finding this shaded part. So you're going to take the circle and subtract away the other shape, okay? So area of a circle minus area of a regular hexagon, okay, which is apothem times perimeter divided by 2, right? And then this is pi r squared. Okay, so we need an apothem, right? This is a 30, 60, 90 standing up, remember? Okay, if it's a hexagon, it's a 30, 60, 90 that's standing up, because this angle right here is a 60, and so you half it and you get 30. So stand up 30, 60, 90, you divide by 2 to get 3 here, and then multiply by radical 3 to get 3 radical 3 for the apothem. Okay, so that's 3 radical 3 for the apothem times the perimeter, which is 3 and 3 is 6, times 6, because there's 6 sides, would be 36, right? So 36 times 3 is 108 radical 3. And the radius is, they gave it to us as 6, okay? So that's 6 squared pi, so that's 36 pi, right? And now that's a perfect answer, but I'm just going to go ahead and put it in and get the decimal form. Minus 108 radical 3, and I get something that doesn't look right. Oh. I didn't divide by 2. That's what it was. All right, so that should have been, let's divide it by 2 all the way across, and then, yeah, I made a mistake. That's okay. All right, so instead of 180, that's 54, radical 3. Okay, so 36 pi. Now we'll get it right. Okay, so 36 second radical, well, 36, won't get it right that way, minus 54 second radical 3, and yay, I got it right now. That's 19.6 inches squared, and that's the shaded part, right? The shaded part. Okay, next one, area of a circle again, pi r squared, okay, minus the area of a triangle. Okay, and since it's equilateral, since it's equilateral, we'll use the apothem times perimeter divided by 2 formula. Okay, the apothem they gave to us, so I can plug that in, 2 radical 3, and I need to work on the perimeter over here, divided by 2, and then the r, we need an r, so that's going to be my r. Okay, so I multiply this by 2, right? So that's going to be 4 radical 3. I could change it to a decimal, but I'll just leave it like that for now. Okay, and then 2 radical 3 times radical 3 to get, you remember this is the lay down 30, 60, 90, right? Okay, so you multiply by 2 to get that one, and you multiply by radical 3 to get this one, so times radical 3. Radical 3 times radical 3 is 3. Times 2 is 6. So half a side is 6. A whole side is 12. So the perimeter is 12, 12, and 12, which is 36. Okay? R, we found to be 4 radical 3. Okay? I could actually square that. Put it in there. Why not? Okay, pi 4 radical 3 squared. So I'm going to square the 4, which is 16. I'm going to square the 3, which is 3. Okay, still got the pi. So this is 48 pi. Okay? This is like taking it and going 4 radical 3 times 4 radical 3, where you go outside times outside, 16. Inside times inside is 3 times 3 like this. Cancel that, a 3 comes out, and it's 48. But you can also square both parts. All right, so 48 pi. Okay, this is 36 times 2 is 72. Well, actually, I can just cancel these 2's. Okay, so this is 36 radical 3, which is a perfect answer. Now I'm going to get the approximation. 48 second pi minus 36 radical 3, hit enter, and I get 88.4 inches squared. Okay, so that's the shaded region, okay, the shaded part. Last one, okay, whenever it's a square, this little triangle is going to be a 45, 45, 90, right? So we got a 45, 45, 90. Okay, if you want the apothem, you're going from the long side to the short side, so you take 5 radical 2 and divide by radical 2, remember? Okay, so you cancel that and you get 5 for this one, you get 5 for that one. Now it's easy. Okay, so the plan, back to the plan, okay, area of the circle, okay, which is pi r squared, minus the area of the square. And we're using the apothem times perimeter divided by 2. Even though this is 5 and 5, so that's 10, so it's 10 times 10 is 100. This is going to be 100, okay? But let's go ahead and plug in. Okay, so that was a 5. The perimeter is 10, 20, 30, 40, right? So let's write it again. Okay, so 5 for the apothem, and then the perimeter is going to be 40, right? Divided by 2. Oh my goodness, it's 100. Okay, like I said. Okay, so pi r squared, r is this. So I'm going to say 5 radical 2 all squared pi. So 5 squared is 25, right? And then when you square the square root of 2, it becomes 2. Okay, so 25 times 2 is 50, and you still got the pi, so it's 50 pi minus 100. Okay, so 50 pi, which is about 150 something or 160, somewhere in there, minus 100 is 57.1 inches squared. Yay, we're done. Okay, have a good day. Bye.